Welcome everyone to today's Passive House Alberta Building Better in Alberta webinar series, sponsored by the Alberta Eco Trust. My name is Frank Crawford, and I'm the Education Committee Lead for Passive House Alberta. Today's presentation will be all about centralized versus decentralized ventilation systems, and which may be more appropriate to your specific project. And joining us is Christina and some of her colleagues from HVAC Systems and Solutions Limited, which are an equipment and supplier in Western Canada. So before Christina starts, I just want to thank Alberta Eco Trust for their ongoing support. It is very helpful in allowing us at Passive House Alberta to continue our work. As always, if you have any questions, please place them in the chat box and I will either ask them at the end, or you can unmute and ask them yourself at the end, because it is supposed to be more of a conversation at the end of the presentation. So with that, I won't take up any more time. Christina, please take it away.
Awesome. Thank you so much, Frank. Thank you to Passive House Alberta, as well as Alberta Eco Trust. Yes, I'm Christina Herbers with HVAC Systems out of our Edmonton office. And yeah, excited to be here with you guys today. We are a proud sponsor of Passive House Alberta. And yeah, I would like to introduce my colleagues, our president, Jivan Thacker, out of our Vancouver office, Peru Kana, and Jack Fox. And with that, I will pass it over to Jivan. But you're on mute.
I am on mute. It would have been a very quick presentation if I was on mute for the next hour. Thank you everyone for attending. Appreciate it. We have a lot of content to cover. Frank, thank you for hosting. Andrea, thank you for sponsoring. Really appreciate that. Today, I think the best way I can describe today, it's going to be like a happy meal. We're going to have a Big Mac, fries, and a soft drink. We have 3 presenters. That way you don't have to listen to me for the next 40 minutes. Let's get into it. Feel free to ask questions. We'll take the questions at the end. Just a quick introduction of my company. This year, we're celebrating our 25th year, HVAC Systems. Our headquarters is in BC, and there's a little map in the top corner there. We look after those territories and projects all over the world. Currently, we're working on projects in the Bahamas, Australia, and Bermuda. So just kind of fun facts. We're in the commercial market, institutional, and in the last 7 to 8 years, we call it now on our website, zero emissions, passive house, high performance buildings. Let's go. Everybody can see my next slide? Yes, perfect. I'm going to just make sure we don't have any lag. I'm going to take my video off for a little bit and then I'll put it back on. Alrighty. Just to give everybody a kind of perspective, we have been working on there are some, believe it or not, Alberta high performance passive house projects. Christina and her team in Edmonton, and we have an office in Calgary. We have done some projects there. Lots to go over. I'm sure there's going to be some questions on how and why those projects came to be, but just wanted to give you a perspective of projects that are already in Alberta that are operating. A little bit of a lag. You guys see me go down the street? They're perfect. Okay, so quick agenda. Decentralized versus centralized. It's an ongoing conversation around that. We have over 300 buildings in BC installed over the last 7 years, so we can give you some insight on that. One of the questions that always gets asked is cost comparison. We are doing that today, so that'll be great. And then we'll talk about individual suite control with Peru in my office here, and then integrated cooling solutions, which is with Jack Fox. And then we're going to give you a little surprise at the end. Okay, just an overview. Again, passive house components. I think everybody's have seen the slide, but we are dealing with the ventilation, comfort ventilation today. Okay. One question that comes up often is Passive House Institute. That's a website if someone wants to take a picture. I know it's getting recorded, but please go to these websites for some guidance, and just from we're a manufacturer representative, so we supply equipment in the marketplace. These are where these equipments are listed, certified. There's a lot of equipment out there in the marketplace. Just be aware of what you're specifying and what efficiency you're trying to hit. And we'll talk about that a little bit today. So I always like to talk about those things because people forget and about those. Okay, right into it. Decentralized HRV, ERV systems. I do have a question. In our climate, it's a 1 hour presentation just to talk about HRV versus ERV. I'm assuming people on this call, if not, feel free to reach out to us later. The difference between HRV and ERV, when should we use it? My answer, short story, if we're just specifically talking about multifamily, please use ERVs. If you disagree, happy to have a conversation with you. Decentralized. Okay, so typically in our experience, 3 to 4 story buildings is where it makes sense. There are some advantages to a decentralized system and disadvantages. So I just wanted to highlight a few things. One of the things for a decentralized system means, again, I'm assuming everybody knows, but I'll slow it down. You would have an ERV per suite, so an individual unit in your suite. Typically, they need a bulkhead on an outside wall, right? Because you need more penetrations for the outside air, exhaust air. Advantage would be individual suite control, but there's penetrations through the building envelope. You got to insulate your ducts. You're increasing your duct size because typically in these smaller units, duct pressure, CFM are a big thing. So you would need to increase your duct work. Motorized dampers, I'm just highlighting some things. And air quality, we will talk about that, but they're limited in air quality. In BC alone, forest fires is a big thing. I'm sure in Alberta is also coming to be growing concern. So just the MERV rating on filters is limited in a decentralized system because of static pressure. And maintenance, of course, you'd have to go into the suite to maintain the unit. Just at the bottom there is our family of products that we range. We call them the Swagon Casa line, but we have them all different sizes. They go as small down as low as 50 CFM. Sorry, I'll go in CFMs, and they go up to the largest one would be even one size larger than that. We're up to 1200 CFM. So that would be a pretty big suite. Typically, we wouldn't do that. You would do multiple units in a larger unit. This is one of our most popular units. Today's presentation is not about products, so I do want to talk about systems, but I just wanted to highlight the skinnier, flat kind of unit that sits in the ceiling space is typical, and then our smaller unit, we call it the R3, would be our next most popular size. I like pictures, so pictures of where these things go. In attic spaces, in multifamily, was kind of a pretty common area. Laundry area, which is a nice laundry room. I wish I had that in my house, but I don't. Yeah, that's kind of my overall summary. I know I can get pretty technical into it. I think just going back with some of the highlights that I would talk about in decentralized units is your outside air, airflow that you need into the space, your temperatures that you need to maintain, and we'll talk about that. But overall, Passive House certified units is an important part of it. That ensures you efficiency, your watts per CFM, and we'll get into that a little bit later. Okay. Centralized systems. So again, I'm just going into centralized systems. We typically see those in four stories and above. Just a small fact, we're working on the tallest Passive House building in the world. So that's kind of a cool thing to say. It's a 69-story multifamily Passive House certified building that we're working on right now. So that'll be kind of fun, exciting, and lots of challenges in there. ERV versus HRV, I think I started by saying, let's have a chat about that. So advantages, disadvantages, right? Centralized systems, one good thing is you got less building envelope penetration. That's a good thing. You got reduced CDC controls. That's specific to our Swagon system. Remote troubleshooting. So all I can give you is examples. We have a building operator that has 20 buildings. Guess how many maintenance personnel they had to operate 20 buildings? It was a multifamily buildings, typically between 20 to 40 suites. That one building owner had one building operator. So can you imagine if you had decentralized units? maintaining those many buildings. So remote troubleshooting is a kind of a key thing for multiple building owners. Balancing of suites, building pressure is always a key thing. Air quality, so I think I was mentioning in BC, we're allowing for MERV 13 filters, but we're also allowing for carbon filters during forest fires and UV lights for airflow. Ease of maintenance, typically in an attic space, mechanical room. Yeah, I think I summarized that. Hopefully my pace is good. There's a lot of content to cover, so I apologize if I am going a little quick. Just giving you a picture. I don't know why it says decentralized. This is a centralized units. This is just in a larger series of our units. That's like a nice picture on the roof somewhere. Yeah, let's keep moving. Costs. So this is where I've done this presentation for Passive House Institute in North America. I've done this in BC. I've done Civics. My presentations are typically an hour and they kind of sometimes run to 3 hours. So I'm trying to limit this to 15 minutes. Overall though, here's what we found out. This cost here based on 2023 projects, so pretty accurate. This was based on 100 suites, 40 tons of cooling, and if you can see my mouse, about 110 CFM per suite. We took into consideration ductwork. We took in VAV fire dampers. We can talk about that. That's a whole hour discussion. We can talk about motorized dampers, louvers, controls, DC controls, in-suite controls, preheaters, defrost. There's a lot to value in the comparison of costs. So we used the electrical people, consultants to give us budget pricing. We asked mechanical contractors to give us pricing. And overall, this is kind of a good thing to kind of take away. If you're comparing just the mechanical system, the centralized system is about a 41% first cost savings, not including installation savings. I don't know what the installation savings is. There is some, right? Handling larger things and one of things versus multiple smaller things is there. But some people may say, well, the ductwork's a little bit larger, so there's labor there. But overall, from an equipment cost point of view, it's 41% savings. That ranges as low as like 38 we've seen, over to as high as 55% when we integrate controls into it. So it's a pretty good number. That's based on, I think we did 20 or 30 projects. I can't remember the number. Guys, do you remember? I think 30, right? Yeah, so that's over 30. That was our range. I'm sure people will have questions about that. Now, the great part is I'm going to hand this over to someone younger, smarter, faster than me. Peru, it's yours.
Awesome. Thank you. All right, everybody see my screen okay?
We can see your screen, but there's a feedback a bit. I don't know if it's Jack or.
Okay, give us a minute. All right, better?
Yeah.
Okay, perfect. All right, thanks everyone for joining. We appreciate your time. And
No, sorry, it's pretty bad. Yeah, anything else you could try?
okay, sorry, let's try that again. Better now?
Yeah, great, thanks.
Okay, great. Okay, so thank you everyone for joining. I will be talking about the individual suite control, as Shivan mentioned. So this is going to talk about the centralized system. What it's going to do is look at some of the benefits and drawbacks, just to recap a little bit of what you guys just looked at with Jivan here. Then I'm going to present something that's called the React damper that will allow you to do the individual suite control within a centralized system. We're going to look at some of the smart add-ons that we're able to do to give you more flexibility in terms of controls and the sequence of operations. And then I will talk about moving forward in design evolution and where Jack comes in and his role with helping you design a project. All right, so centralized system benefits, just to recap here. So it'll be a lower first cost, as you saw on the last slide that Jivan was presenting. It also does tend to have a lower maintenance cost just because everything is centralized. You don't have to go into each suite to do access, so it does turn into some cost savings. You can also provide heating and cooling with a centralized system. It's much easier. In our solution here, what we'll do is we'll put a DX coil paired to a heat pump outside, which will give you full cooling, full heating. There's a little bit of more information on that coming up, which Jivan will cover. However, one of the drawbacks we see with the centralized system can be that there's a lack of controllability. If you just have the one air handling serving all the suites, it may not be to everybody's liking. Therefore, we need to come up with a way to have a more demand control sort of approach, and that's what we're here to cover. So how we do that is by using React dampers. Now, the React damper looks like that. And what it can do is it can modulate the airflow in each individual space. So the idea here is that you'll have a pair of these in each suite, one for supply, one for exhaust. They will talk to each other and ensure that the suite is always balanced. Now you can vary the airflow on a variety of parameters. Some of them are listed here, so you can do it based on space temperature, which would be kind of a very basic controls logic there. You can do it with space humidity. You can set it up for demand control ventilation, CO2, VOC, or occupancy. We see this sometimes in amenity areas and such, where they have it based on occupancy or VOC. And then if you are working on passive house, since this is all about passive house, you need to be mindful of your normal, boost, and away modes, which is something that we can dial into our React dampers. So that way you can always modulate and use the least amount of energy. Now, this may just be sounding like another VAV box, which in essence it is, but there are a couple things that make a difference. So first off, it's got a very low pressure drop. We're looking at about 0.2 inch pressure drop for the damper. Usually when I do a quick survey in a room, people are used to, half an inch, 0.6 inch pressure drop across the dampers. So using the React dampers does result in potentially downsizing your equipment. So your fans are not working as hard and you're able to, release the pressure there a little bit. The second thing about the dampers is they come with a very high turn down ratio. 10 to 1 is typical. We've seen some of them go 12 to 1 or higher. And the other thing is these are on the conservative side. So this gives you more uniformity in the building. You'll have the same size of dampers serving multiple spaces. It's also got communication to the central unit. So all that means is they don't have to be hardwired back to the central air handler. They're going to work actually based on pressure. And then lastly, they will all have airflow sensors built in. So in addition to having them in the suite, we also put them at the main branch offs and stuff like that, just as an added practice, so that you can do, it can help with balancing, it can help with troubleshooting, because usually in a passive house building, you're not dealing with much airflow, so every bit of airflow is critical, so we need to ensure we know where it's going and track that accordingly. All right, now I'm going to cover a little bit, just briefly, some of the control sequences we can implement. I'm not going to get into it too much, as this is what Jack looks into, so I'll get him on that. So this is a very basic diagram on the right here. So you'll have a supply damper, like I mentioned, one for exhaust, so there's the pair. And in this scenario, it's just got a humidity sensor and a repellent bulb. So all you're doing here is you're just doing the airflow with the normal boost and away modes. We look into the next step over. This is a fairly common approach as well. So in addition to the React damper pair, you have a supplementary baseboard heater and a temperature wall. So this will involve a little bit more complicated sequence of operation. But again, the whole idea is to have everything programmed. And then lastly, you can have kind of, if you wanted to introduce some free cooling and mechanical cooling into the space, like Jeevan mentioned, you can do full cooling. So as you can see here, this is your central air handling unit, and it's got a DX coil with a condensed unit attached to it. Same idea in the suites, you've still got a baseboard heater for heating if you wanted to top up. However, your cooling will now come from here. You'll have an apartment sensor, thermostat. So part of our job is to come in, have a conversation, and set you up with the right components and the right sequence of operations to figure out what you need to achieve for your project. Now, some of the add-ons, as we've gone through the years, we've had requests from engineers saying, hey, I want to look at tying in my washroom exhaust to my dampers, my kitchen exhaust, what happens when somebody opens a window, I want to save that energy. So essentially what they wanted to do was give us some custom points that they wanted to add to their React damper. Now, the controller that we use has, I think, 3 inputs, and if you need more, Jack is able to work his magic and actually provide a more robust controller that's going to give you, I think, about 6 inputs. So you have more flexibility there, and he will be writing the control sequence, the operations, and all that stuff on this controller. So it's basically a blank slate, and Jack is your artist. Getting into that a little bit further, this is the custom control sequence we did for a project in Vancouver. So I'll let you guys have a read, but the essence is that they wanted to counter the overheating setting. So if it gets too hot in the space, they will trigger the React dampers to go into boost mode. When the washroom exhaust is on, the dampers will go into boost mode. Kitchen hood, same way. And also we have thermostat control the electric baseboard heater as well. So it was all tied into one system, kind of a single point responsibility, and that's what we achieved for the client. Okay, and that's all I had. I will be handing it over to Jack, who's going to take it from here and get into oh, sorry, 1 second. Actually, my bad. It's going to be back to Jeevan for another couple slides. Thanks, Drew. Oh, let me just mute.
Perfect. Thanks, Prue, for handing that off to me. Can everybody see my slide? Yes, thumbs up? Yeah. Okay, awesome. I think I started by giving everybody a Happy Meal kind of an experience, right? Big Mac, fries, and a drink. So I'm back, and let's talk a little bit about cold weather. How does that affect our HVAC equipment in your building, in your high performance buildings, in your passive house certified buildings, your net zero buildings, all the names that you guys and girls remember and talk about. So Swagon, specifically about this product. What if we had to build an ERV in the marketplace for cold weather climate? What would be the number one thing we wanted to do? Well, we'd want it to operate at low winter conditions. What if I said our unit can operate at minus 40 C without a preheater? Okay, let's think about that for a second. What does that really mean, right? Why do we need that, and why does that make a difference? One criteria is being passive house certified as a unit. Number two, you want your watts per CFM per square foot as low as possible to achieve your passive house. So if you could run a unit at minus 40 C without a preheater, that electric preheat or hydronic preheat, all that energy that's getting used for that gets taken away out of your watts per CFM per unit. So it's kind of a game changer. Third thing, a humidity control. We've got over 300 projects installed in the Pacific Northwest. In the earlier days, 7 to 9 years ago, I think we've been doing this for that long, we just had HRV units. We had no humidity issue. We didn't allow for humidity issue. As I'm sure everybody on this call knows, humidity is your number 2, actually, not number one. Number one is passive house projects, high performance building envelopes are causing buildings to heat up. So cooling is your number one thing to fix in passive house high performance buildings. Number two is humidity is what we're seeing. So if we could have a unit that also deals with humidity control, that'd be also a good thing. There's some wording on this, but I just wanted to kind of talk about that. So that's when you're designing, if there's designers on here, if there's end users, be mindful of, don't just pick the unit, any units in the marketplace on efficiency. Don't get stuck on that. Look at the actual watts per CFM and how you're achieving your unit. Okay, I promise I only have a few slides on this. We did a case study. This was in Calgary. We ran some Calgary numbers. I think we have a lot of time into going into the numbers. I'm sure people will have questions, but anyways, we've done that. We did site charts. In Calgary, we noticed that there was over 1751 bin hours in the difference of when low temperature operation of an ERV. I can get into the details of that, but anyways, so we're talking about frost control, defrost control is a big part of the success of this unit, but in the marketplace, that's what you got to be mindful of. Don't just focus on efficiency. How is the unit going to operate in winter mode? Anyways, this was a number, it came out, it was $11,423.52 savings per year by picking a different type of unit that would run. Again, this is an energy efficiency and watts per CFM focus project. Not all projects are like that, but the projects that we're focused on is these things apply. Last thing, I like pictures. It's easy to kind of show. There's some numbers on the side that are probably a lot of people on this call will say, yes, I understand why 8620.45, but some may not be familiar with. But I want to focus on our earlier designs. Back in the day, we would design an ERV in the space. Can everybody see my mouse when I circle something?
Yep.
Okay, good.
Yep.
So no cooling, and we would basically bring outside air, and with our device of heat exchanger, whether it's a wheel or a core, we can get down to 20 degrees Celsius. So that's why it's in red. There's some kind of tricky numbers in here, but happy to explain that, but if I had more time. So that's kind of the first stage, just kind of ventilation air. Then we got a little bit smarter. Every year, I hope we do. We were challenged by the industry to say, hey, what if we provide, and I call it tempered cooling. It's not full cooling, but tempered cooling. And what we did was integrate a VRF DX coil with a heat pump, and now you can achieve into the space, this is room space, of 16 degrees Celsius. We've got some react dampers here, some VAV individual suite control. I think Prue already explained that, but I'll let Jack, who's coming up next, to explain that. And then our third design, again, a year later, we can now do full cooling. So if I said there was 10 projects that we're working on, 8 or 9 of them are in full cooling. That is what the market's looking for, is full cooling mode. And we can achieve in the same design down to 12 degrees Celsius in the space. Okay. And that was it. I was just short and sweet for that. Jack, again, I'm passing it over to Jack, younger, smarter, and more smiles than me. Jack Fox. Take it away.
Thank you, Chetan. Let me just get my screen on, load it up. Can everyone see my screen?
Not quite yet.
Okay, give me a second here.
Yes.
Yeah.
Okay, perfect.
Yeah. Okay, perfect.
Okay, awesome. Okay, thank you very much, Jidan. Okay, so this next segment is going to be tackling controls. So high performance equipment requires a level of sophistication that really kind of squeezes out the most efficiency out of the equipment. Before I go on, I always like to introduce any discussion around Swagon controls with a little fun fact. Most people don't realize that Swagon actually started as a controls-focused company over in Europe, and then they eventually got into the high-performance HVAC equipment space. Why that's important is because it gives context into how much thought actually gets put into their control system across the board, whether it's their centralized flavor of VRVs or decentralized flavor. So to introduce the control system, so every single unit gets shipped with a PTL certified BACnet IP-based DDC controller. It comes with a fully comprehensive suite of sensors, various components designed to allow the unit to run in a standalone fashion. And what I mean by that is it doesn't require any sort of third-party system, whether it's a building automation system, telling the unit what to achieve. You simply tell the unit what sort of regulation strategy you want to accomplish, and the unit does so automatically. From an integration perspective, it's a single point Ethernet connection into the unit controller. With that in mind, any building automation system can easily pull out over 2,000 BACnet objects. From a passive house community perspective, there's a lot of interesting things that are being generated in the background. Things like specific fan power usage, represented as watts per CFM, various energy recovery metrics. It's quite a comprehensive list. It also comes with a complete suite of control algorithms designed to suit any sort of application, whether it's a constant volume regulation strategy, variable air volume. We can also control to indoor air quality with duct-mounted CO2 sensors. The system itself is incredibly flexible, so we can integrate external components, things like preheaters, various coils. Like Jivan was saying, we have a ton of installs with various VRF manufacturers. Another interesting thing is Swagon implemented fire smoke control sequences. And with that in mind, we can monitor things like duct smoke detectors, fire alarm control panel contacts. So in the event of a fire or smoke condition, the unit can be configured to either help with smoke evac or shut down entirely. It's quite flexible. Next, I want to talk about the IQ Navigator, which is the Swagon Gold Systems user interface. So with this, building operators, technicians, energy managers can access every single operational parameter, the sensor values. Another interesting bit is that the unit comes with real-time and historical trending. So that makes system tuning and monitoring the energy consumption and usage quite flexible and readily available. I want to take a couple of minutes to talk about defrost and how Swagon approaches the inevitable element of ERVs and HRVs being defrost. So anytime you have humid air meeting cold outdoor air, the likelihood of frost forming is quite high. Where other manufacturers of ERVs typically utilize outdoor air dampers to help with a defrost condition, what we are doing is quite different. The only element that we are changing when the unit senses a defrost condition is manipulating the speed of the energy recovery rotor while leaving the fan speeds and dampers as is. So why that's important is in a period of defrost, we are still meeting outdoor air ventilation requirements and feeding fresh air to the space. And again, the only thing that we're changing is the speed of the wheel. On the right-hand side, you can see a chart. So at max heat recovery effectiveness, we are utilizing our stepper motor to rotate the speed of the wheel at 20 RPM. And in a defrost condition, we are modulating that speed down to a minimum rotation per minute of 0.5. Even at 4 RPMs, we're still achieving 60% energy recovery, which is huge. Next, we're going to talk about CASA controls. So CASA being the Swagon Gold's little brother, designed for more, I guess, residential applications, but even more like common space type of systems. The same sort of breadth of controls is packaged together in CASA controls. So as a user interface, every unit gets supplied with a Genius wall controller, which then connects to a mobile app. So users can easily log in, change set points, switch between different modes, just from their tips of their fingers using their smartphone. Again, when it comes to integration in mind, Swagon's thought of it all. It's quite a modular system in the sense that it supports various add-ons, things like hydronic or electric coils, indoor air quality packages, cooker hood monitoring. We can also tie in controls for bathroom exhaust switches. We also have lots of deployments where a building automation system would like to monitor the status of their CASA unit. So that sort of integration is done through BACnet or Modbus.
Are we just trying? Okay, thanks, Jack. And now we are on to our presentation. So
we've done the presentations. Hopefully there was
Oh, we can't hear you. Sorry.
Hello, can you hear me?
No, we can't.
Hello.
Yeah, now we can. Yes.
All right, perfect. Yeah, so thank you, Jack, for that. Now we're going to transition to the last part of our presentation here, which is a bit of a surprise, and we actually have a live demo of all the things we've talked about. Can you guys see my video?
Yes, we can.
Perfect. There's Jack, and he's going to talk us through the demo that is behind him.
Perfect. Thanks, Farouk. So here at HVAC, we do a ton of road shows. We do a ton of presentations. Obviously, we're very involved in trade shows. It's very easy to simulate what a decentralized system looks like just by wheeling in a CASA unit. But what we want to do is also provide users the ability to see what our take on a centralized system is comprised of, which is why we put together this demo rig behind me. So to kick it off, let me introduce you to our centralized HVAC system design, starting with our dedicated outdoor air ERV, which is essentially feeding air to the space. We have here also simulating a particular zone. So if you could imagine, you've got this either in a mechanical space or sitting on the roof. All that tempered fresh air gets then distributed throughout ductwork into the building. And then right here is where we are controlling the air quality within a particular zone. So to show you what that looks like, in essence, we've got damper actuators on both the supply and the return side of the our React dampers. These guys are networked together so that when one opens, the other one does so proportionally. The two of them get controlled by this Sniptronic thermostat, which is designed right now to maintain an indoor air quality set point, such that when the unit detects an elevated amount of CO2 in the space, it automatically controls the supply damper to open, allowing fresh air to enter the space. The return side then opens as well to balance out the flows. That change in air pressure in the supply duct gets picked up with duct static air pressure sensors. And given that we are controlling right now to a variable air volume regulation strategy, the unit automatically ramps up and down the speed of the fans to ensure adequate ventilation throughout the building. To give you a bit of a closer look, give me 1 second here. Everyone see my screen? No. Nope. Okay. Maybe I'll skip this portion. Let's crack open the hood of the ERV and just talk about some of the major elements of the unit. So the first thing you're going to notice is just how wide the energy recovery rotor is. Measuring at 16 inches wide, that's how we're able to achieve such high latent and sensible energy recovery. So we're talking, you know, high 80s across both. We've got ECM fan motors that are acoustically tuned. So the unit, when it's running, is super quiet, very efficient. We've got differential pressure sensors that, like what we talked about earlier, help out with our defrost control strategy. We're also using differential pressure sensors across each filter bank to track filter loading. So we are not replacing filters preemptively. We're actually telling the unit when the units need to be changed, when the differential pressure has exceeded a given threshold. Another interesting feature, like I briefly touched on earlier, is because the unit has all the sensors that it needs to run in a standalone fashion for constant volume applications, Swagon's actually embedded airflow monitoring stations in both supply and return fans so that it could meet that sort of regulation strategy. If there are any questions at all regarding the control system, I invite you to reach out to Christina or myself directly. We'd be happy to schedule a call to go through any questions. And over back to my team.
Okay, so that is the end of our presentation. Thank you, Jack, for the demo at the end. And now I believe we will open it up to questions.
Yes, excellent. Thank you all very much. Very data-packed, but very clearly articulated presentation. Thank you. So if anyone has any questions, feel free to just put your hand up or unmute. I kind of have one question that I kind of will start us off. So I think maybe talking more on the smaller CASA-sized, either decentralized or for residentials, how much do we have to worry about sizing the unit, or is there much of a big cost difference to go up from the smallest to the next size up of those CASA units? Just when we're thinking about how much duct friction loss or air tightness loss we might have in the system. Like if we had a building or a house that needed 150 CFMs, what size of CASA do you think would be the most appropriate to buy? Or do you just always upsize one because the equipment cost isn't much difference?
Yeah, great question. It's Jivan. I'll take that question. So you're not going to like the answer. It depends, right? So, but here's kind of the criteria. So number one, before you buy something from us, we're going to ask you a bunch of questions. We want to make sure we're picking the right unit for your needs. So question number one, are we doing cooling? So cooling decides basically your first criteria, the sizing of your unit. And here's why I say that. We've gone into a lot of experience on these. Your cooling, you're going to need a certain amount of CFM through your DX coil, through your heat pump to enable proper cooling. So we call that boost mode. Now we call it super boost cooling mode. There's different names for it. That's going to determine your sizing. But physically, if you went from a CASA, the smallest one's an R3 to an R5, I think they're increments of maybe $500, $300, something like that. It all depends, but I think you got to start with how much CFM do you need in your space for ventilation mode, and that's a criteria that everybody works on. And then the next question is, do you want cooling mode, and what type of cooling? Tempered cooling or full cooling, and then it'll determine your size of your ERV.
Okay, and I guess the only thing to add on is when I guess most of your systems get commissioned, when you go back, how much friction loss are you seeing from what CFM the fan puts out to when the CFMs actually come out the
Yeah.
diffuser at the end?
Yeah.
So I guess how do you incorporate that into the sizing of the units?
No, great question. Great, great point. So be mindful of that because you are going to see that. With one small decentralized unit, whoever's it is, you're going to try to duct that into the largest suite. You don't want multiple units, right? Because multiple units are very costly per suite. So you're going to do one unit, lots of duct work into a 1-bedroom, 2-bedroom, 3-bedroom. We've seen that happen. So the duct losses are great because most passive house projects want to use a 3-inch, 4-inch duct. And then you hook that up to an ERV, a smaller ERV. They just don't have the fan horsepower to do it. That's just a general statement. The CASA, the unit that Jack had showed a demo called the Gold unit, that's a ECM, super high-tech unit, large centralized systems, right? Multi-story building. We can do up to 3.5 inches of external static. But guess what? The Gold swing-on unit, they took that same technology and brought them into the CASA. We actually have ECM motors in our CASA unit, and we can do up to 3 inches of static with that. So that is kind of one of those things to be mindful of. But from a design point of view, be careful. There is always going to be losses.
Yep, thank you. All right, question. So question from John, I think John was, Jovan kind of said the difference between the VAV box and a React box. Maybe just answer that briefly once more. What's the difference between those kind of two types of equipment?
Yeah, I can take that one on. Thanks, John, for the question. So yeah, it's essentially a VAV box. However, there are a couple of differences. So one is you're seeing a lower pressure drop in the system. So the React dampers only give you about 0.2, and that is being conservative. So you save a little bit of fan horsepower there. The second one is going to be the turn down ratio that they provide. So anywhere from a 10-to-1 to a 12-to-1. So you're able to modulate your airflow a lot more if you're designing a demand control ventilation type of a project. And the third one being that they work independently, kind of based on pressure, but they do communicate all this back to the central air handling, which would be your Gold heat recovery that Jack pointed out to. So it's more of a connected system, and you're getting a little bit of benefits compared to a VAV box as well.
Excellent.
Sorry, can I add to that a little bit? Just I like examples, right? Real life examples. That 69-story building that we're working on, the engineer had some challenges. They wanted the ductwork to be small. It's passive house certified. Then they went with a VAV box, a traditional one, which is fine. But typically a typical VAV box in the industry has about 0.4 to 0.5 inches of static. That's number one. Number two, their airflow range is only about 50%. So these things, I call them precision VAV boxes. We can do a 12-to-1 ratio on CFM. So 120 CFM unit, we can get down to 10 CFM, which is kind of crazy. And then we design our systems to 0.2 inches of static. So all this again helps the watts per CFM that I originally spoke about.
Thank you. So Leonard, I like that question. So there's a lot of talk now about kind of missing middle and higher density kind of residential sized buildings. So once we start sticking multiple units together, or even in multifamily, when we try to stack them, we often have fire separations or smoke separations that we have to cross. But depending on what that fire separation is or how the building's set up, using one piece of equipment for 2 or 3 units has equipment savings. So you can talk a little bit about how and if you're able to cross fire separations, what type of dampers are, the cost to do those dampers versus putting in a whole nother unit.
Yeah, it's a great question, and it's a very hot topic in our presentations here in Vancouver too. So I'll go to a real life example. Is we actually work with one of the code consultants here and the city of Vancouver. So what we've done is we have a way of not manipulating, but still complying with the code. But what they need is for us to implement certain control sequences with our Swagon unit that gives them a peace of mind on what happens when there is a fire. So Jack actually had sit down with the city of Vancouver and the engineer and the code consultant, and we have control sequences for fire operations and smoke operations and, you know, all the emergency power hookups. Basically, you're doing all these things in order for them to be satisfied with our approach, and that's kind of how we're dealing with that, the new code that's asking for the separations. So it's a fire and smoke dampers in the suite combined with the control sequence of operations that we program into our units.
Okay. And does I guess the fact that the CASAs don't recirculate any of the exhaust air for defrost, does that help because you're not recycling the smells from one unit back to another unit, or the smoke from one unit back to another unit? Like, could you do that with a recirculating ERV, or it has to be one of these CASA types that don't recirculate?
I can jump in. So it's definitely the hottest topic that we've encountered the last 2 years. So the biggest challenge in that is I love the centralized system. I love the 40% savings, but now I got to add these VAV, smoke dampers, fire dampers. So Swagon recognizes that. Internationally, they've come up with a way in their control sequence to satisfy all the city requirements. And that's what we're doing, and we're implementing that. And that was a big savings to the owner. Can you imagine 69-story? I think it was like a 3,000 fire dampers that we eliminated on that tower. So pretty big substantial savings, right? Just to answer your question, decentralized systems, you don't really need your fire separation smoke dampers because you have your ERVs in each individual suite. But I think did you talk about airflow quality or versus centralized versus decentralized, or no?
No, but I guess it's a good segue. So I guess where are you placing the MERV 13 filters are obviously before it hits the core. Where would you put your activated charcoal filters to kind of be able to change that or improve the indoor air quality?
So fortunate, we are somehow the champions in fire halls. It just happened the last few years. We've done over 15 fire halls with, like, some are passive house certified, some are high efficiency buildings. And we kind of work with the fire departments on that. So our standard units are MERV 13 bag filters. What that means is it's a 22-inch cabinet of filters. So when a fire season comes, instead of adding another carbon filter section to it to add static to your whole system, recalibrating that, redoing the static, we've now designed, we've worked, actually, as myself and my team worked with a Canadian manufacturer in Ontario with a filter manufacturer there, and it took us 2 years to get a a carbon filter, 22-inch carbon filter. It doesn't sound exciting, but it has the same static pressure property as a MERV 13. So we've designed our unit now during fire season. The firefighters, for example, for the fire hall, they would go into the unit, slide out our bag filters, put in the carbon filters, no change to airflow, static, or anything in the system. I think that's part of the reason why we've successfully completed 15 fire halls.
Cool. Is there a similar option for the CASAs, the smaller ones?
Working on it. It took me 2 years to work on the gold, and we'll try to get there. It's challenging though. The static pressure is a challenge for sure.
Yep, definitely. On a similar vein, I think maybe more for the smaller CASAs or even for the larger ones, I know I saw a picture there of a kind of duct silencer. Can you talk a little bit about the different ways that you can silence the sound of ERVs? Because passive houses are very quiet, so I want to make sure the ERV sound doesn't transfer. Is flex duct enough, or do you want like specific designed acoustic ducting?
Is that you asking, or is that the panel asking? Because great questions.
A little of everything.
Okay, good. So here's what we can say, and then here's what I would recommend. If there's designers out there, if there's building owners out there, you build this fabulous building for your tenants, rental or owners, The first thing after it's built, commission, everybody's happy, signs that off, and you walk into an occupant in the building, and you go into their building and you say, how's your building doing? Or how's your suite doing? How's your apartment doing? How's your townhouse doing? And the first thing they say is, this ERV, it's off. We turn it off because it's so noisy. It's either in the bathroom, it's in the hallway. We don't like it. So that is the number one thing that we see issues in the marketplace is once it's installed, please, anyone that's in the construction industry that's part of your project, please go see the occupants that are living in it. That's how you know you're doing a great job. The answer to the question is when you're specifying things, I kind of focus today on don't look at the energy number, look at how the unit's going to operate in the winter. That's kind of, I think, the first number one priority. I think the second one is what is this unit going to do and what's the sound levels going to do when it's in winter mode, in defrost mode, and summer mode. You want this thing to be quiet. So ways to mitigate that is we have we call it a CLA duct silencer, but Swagon has a policy out of the box. So you buy this, it ships on site. We're NC 32 or lower, right out of the box, guaranteed. If we are louder than that, they supply their own in-house made silencer free of charge. So some of our projects, whether it's ductwork that was smaller, we've supplied a few extra silencers, not very costly, but we had to go in a couple because they know someone did complain and we went and tested it. It was noisier. We ended up Swagon supplying a silencer for it. But we recommend not at starting, but sound's always an issue of these things running.
And I guess the sound from the boxes, all the boxes, the equipment itself is fairly air and sound tight. So can you just put these in mechanical closets, or if you put in a mechanical closet in like a living room, do you still want to kind of acoustically isolate the doors?
Great question. So in Europe, they put these in the kitchen cabinets. That's how quiet they are. So that's why there's a guarantee. NC 32 or 34, somebody else can quote me on that. There's probably a brochure on it out of the box. So do not insulate it. Part of that, if you're looking at comparison products out there, leakage rate is a big part. There's a passive house certificate that you need for a unit, but the leakage rate on the passive house certificate needs to be 3% or less. And for us, or the Swagon Casa, it's 0.45%. So can I say that again? To be passive house certified manufacturer, you need to be less than 3%. The Swagon units are 0.45%. So that helps with the noise.
Definitely. All right, we're coming up to one, so maybe one more question, follow up from John. So when you're talking, can you, I guess, elaborate a bit more on the frost controls and the watts per CFM and kind of why the winter concern is more of a concern than maybe just the whole annual watts per CFM or electrical consumption?
Sure. It's G-Man, I'll take that one. Great question. And again, this is we do a presentation just on that. So I'll pause for a second. Please reach out to Christina. She's in my Edmonton office, and there's Jack on the controls. Happy to do presentations for everyone just on that. But let me kind of just do it high level, and then we can, I can answer this thing for an hour, right? So frost control. What happens when the unit goes in frost control? I'm asking the question, right? So if the unit is the core, whatever core it is, a wheel or heat exchanger, if it's in frost control, what typically happens is the supply fan shuts off. That's how all manufacturers do it. And what happens is they ramp up the exhaust fan, try to bring that warm air against the core to defrost the core. But when it's in frost mode, what's your efficiency of your unit? Well, they stop the core, they stop the wheel. Your efficiency is 0. There is no efficiency. So be mindful. And maybe the last takeaway would be mindful when you're doing selections. Make sure, whether you're working with HVAC systems or other manufacturers, run a selection based on ventilation mode and winter mode. And then you'll be able to see what your unit's operating at. So that's number one. Number two, just be mindful if you're bringing it outside -30, let's talk about Alberta, and you can defrost that, or you don't go into defrost mode because we have a wheel, then we can slow down the wheel to 0.45 RPM. Typical wheels are typically 7 to 15 RPM. We can go down to 0.45 to prevent frosting. And what that does is when we slow our wheel down, if our unit was 86% in ideal conditions, efficiency, when I slow it down to 0.45, what do you think the efficiency goes down to? When we talked about a typical unit, when the supply fan is zero, supply fan is off, 0% efficient. But if a Swagon unit, if we need to go from -30 to defrost mode, we drop probably between 8 to 10% efficient. So we'll go in winter mode, maybe at 75%. We have to run the numbers, or 72, could be 80. So be mindful of when you are selecting the right unit. That's what it is. And I think the third part was, what's your watts per CFM? Just high level, keeping it simple. If you have a preheater operating in winter mode, it's sucking energy, it's creating dollars per watts, right? If you remove that heater, you're saving that watts for that usage of that unit, which most passive house certified people in their programming, in their selection for their building certification, they would eliminate that part. So it's a big part of your building consumption if you don't need preheaters. We just won a project in Edmonton. I think it was a 300 unit project. And the owner was ready to cut a PO to our competitors, which is fine. It didn't seem like a lot, but think about this. They had a 2 kilowatt heater for 300 units. That's 600 kilowatts. Doesn't sound like a lot. Maybe it's a lot. But we came in, our price was more, but we had no preheater. So we saved them 600 kilowatts of running per month, times years, times whatever, 15 years. It's a big savings.
Yeah, there is definitely a big difference between the wheels and the cores. And yeah, we could spend all day on this, but
Yes.
I think we're a little bit past 1 o'clock. So if there's any other final questions, then thank you, HVAC Systems and Solutions, for your informative talk. Thank you all for coming to the Passive House Alberta Building Better in Alberta series, sponsored by the Alberta Eco Trust.
Yeah, thank you. Feel free to reach out. I think Peru is just going to put our contact information, but Christina, reach out to it. Frank, thank you. I think Andrea is still here. Thank you for sponsoring. That's great. And thank you for having us.
Thank you all.
Thank you all.